So welcome back to the course. In the previous lesson, we spoke about rainfall, clouds, precipitation, and how they may change in the future. Now we're going to talk about clouds in this lesson, because clouds are actually extremely important for the climate system, not just for producing rainfall, but also for reflecting sunlight back to space, but also trapping in the heat from the Earth. As we mentioned before, every cloud droplet and every ice crystal form on a tiny nucleus, a condensation nucleus or an ice nucleus. Then they have to grow by condensation to cloud droplets. And as we mentioned before, they have to then eventually collect together to form rain droplets or snow. These little particles, whether they dry particles, wet particles, or ice particles, we call these together atmospheric aerosols. That's the name we give to them. Aerosols are tiny particles. They're in the atmosphere, and they're so small that they stay more or less suspended in the atmosphere for very long times. They can have sizes from 2 to 100 microns, where a micron is 1/1,000,000th of a meter. And because they're so small, they're very small fall velocities, about a few centimeters per second. So if they're up at a few kilometers, it'll take them a few days actually to fall down to the surface if they're not blown around by the wind. And if we look at the concentration of these droplets in a cloud, we normally have a few hundred per cc. So if you take a centimeter cube, in a cloud you maybe have a few hundred of these droplets. And if you take a small cloud of maybe 1 kilometer by 1 kilometer by 1 kilometer in volume, you may have 10 to the 17 droplets in that cloud. So a huge number of droplets which are floating in the air inside the cloud. Now let's talk a little bit about the different types of clouds. We can divide the clouds up firstly by different altitude in the atmosphere. We have low clouds, middle clouds, and high clouds. Normally the low clouds are associated with the word strato, which is for a layered clouds. The level is always from the surface, but it may go up to different levels, the clouds in different regions, from the tropics to the poles. Normally the low clouds are up to about 2 kilometers altitude. The middle clouds, which we normally have a name alto connected to them, in the tropical regions they may go from 2 to 8 kilometers, where in the polar regions maybe 2 to 40 kilometers. And then the high clouds, which we normally have the word cirro attached to them, can go up to 18 kilometers in the tropics and maybe 8 kilometers in the polar regions. And we can see the different types of clouds here in this sketch, where the high clouds, again, they can also be written by these different letters: CC cirrocumulus, cirrostratus, and the cirrus clouds, the wispy kind of feather clouds that you see in the sky, the altostratus, which are middle layered clouds, and the cumulus clouds, the altocumulus, and as we come down lower to cumulus, stratocumulus, and these two other non-layered clouds, the nimbostratus you see on the right and the cumulonimbus on the left. Now what do these names actually mean? So cirro, where we see the cirrus clouds and the cirrostratus, these are clouds which are made only of ice crystals. So the very high clouds, the wispy clouds, are basically made of ice, only ice crystals. Alto are the middle clouds, but these are made up of the supercooled water. We saw in the previous lesson that you can have water below 0 degrees. So we can have supercooled water droplets together, sometimes with ice, but normally these altostratus, altocumulus are only water droplets, but below 0 degrees. The strato, again, means a layering of the clouds, and it's normally layered clouds which have a much larger horizontal extent than the vertical. Cumulus actually means heap or mass, and so these are lumpy clouds, like the cotton wool clouds you see on a fair weather day. These are the cumulus low clouds, but altocumulus or cirrocumulus also mean that you can actually see some structure. There's some mass and gaps between the clouds. And the word nimbus means rainfall or precipitation. So when we have on the right nimbostratus, these are layered clouds across the sky which are producing rainfall. And you also have the cumulonimbus on the left, which are these massive clouds, these cumulus puffy clouds, which also produce rain. The cumulonimbus on the left-hand side have a much larger vertical extent than the horizontal extent compared with all the other clouds. All the other clouds are much larger horizontally than they are vertically. The cumulonimbus, the CB clouds, are much deeper vertically than they are horizontally. Now, if we look at where the clouds occur around the planet, here we can see some satellite images going from January 2000 all the way to July 2022. And the white areas are showing the fraction of clouds. So this is going from 0 to 1 or 0 to 100%. And what we see is that more than 60% of the Earth is covered by clouds at any time. So most of the Earth is actually covered by clouds. And these clouds, we know them, are white in color. And so they actually reflect the sunlight. And as we've seen in previous lessons, they impact the albedo of the climate and the temperature of the Earth. The more clouds we have, the more reflection and the cooler the Earth will be. The less clouds, the more solar radiation can come to the surface and the warmer it will be. You can also see the motion of the clouds as a function of the seasons, moving north and south. So we'll talk a bit more about these patterns during the course. But the bottom line is most of the planet is actually covered by cloud cover at any time. So from now on, we're going to talk about how these clouds impact the radiation balance, the Earth's radiation, the incoming radiation from the sun and the outgoing radiation from the Earth. And as I mentioned, these clouds can modulate the climate. The more clouds we have or less clouds will actually impact the temperature of the Earth.